A part is in exponential form. It's in exponential form. So you've got two ways that you can solve exponential problems. The first way we want to try to solve them is we want to rewrite both bases with the same base. So on the left side, I have 2 as a base. Now, can I rewrite 32 to have a base of 2? I can. What is 32 in terms of 2? Let's say 2 to the first is 2, 4, 8, 16, 32. Right, so 32 would be 2 to the 5th. Now I've got 2 powers that are set equal to each other. So if the powers are equal and they have the same base, then what does that mean? That means the exponents have to be equal. As soon as I make those bases agree, I can basically drop the base and say the exponents must be equal to each other. So this says x equals 5. That's always the first way I want to try to solve these. Any questions on A? Any part of that? Okay, B part. Again, it has multiple ways we could solve it. Now, because I have a 0 on the other side, that means anything I move over there automatically becomes the only thing on that side. So, if you remember, we had some problems earlier where I had a natural log on one side and a natural log on the other side, and they're both set to be equal. Well, that means we can just drop the logs. There's no reason to even say them, that the arguments have to be equal. So since these logarithms have the same base, then if I can make them be the only thing on their side of the equation, then that means I can drop the logarithms. So I've got a log base 4 of x equals a log base 4 of 8. Drop your log base 4s, which means x has to equal 8. Any questions about how to do those? That's the way I would do those two problems. That's the quickest way. All right. Now I'm going to show you another way you can work them because sometimes you might have to do this. All right. So like if I look at A, say that I didn't know how to write 32 as a base of 2. Okay, then what I can do is rewrite this from exponential form to logarithmic form. So in a logarithm, this would be log base 2 of 32 equals x. And now this question, we can either answer it in our heads or we can use our calculators to plug in. This says 2 raised to what power is 32? Well, we discovered that earlier. It's 5. Right? So that's another way you could solve the one on the left. All right, let's do another way you could solve B part, the one on the right. What do I have? I have logs being subtracted. What can I do when logs are subtracted? I can rewrite it as a single logarithm as division. So this would be log base 4 of x over 8 equals 0. Right, that still follows the law of logs. Nothing wrong with that. And now what question is this asking? This is saying 4 raised to the 0 power is x over 8. Right, so what am I doing? I'm rewriting it from logarithmic form to exponential form because I know what 4 to the 0 is. 4 to the 0 is 1 equals x over 8. And then we can solve, right? Multiply both sides by 8. And that tells me x must be equal to 8. So why did I show you all these ways to solve it? Because there's not just one way to solve any of them. Right? As long as you use the properties of logarithms to rewrite it, and you follow it through, then you can get a correct answer. The one thing you can't do, and I said it first once, I'll say it again. If you sit there and try nothing, you're not going to get it right. Do I know how to start every one of these problems? No. I just pick something. Sometimes I'll do it, run into a dead end. All right, start over. Think about it a different way. That's fine. Do your best and forget the rest. Okay, so what did y'all do on C part?
Canceled out the natural logs.
So did you move the negative one over?
Yeah.
Okay. You can do that. And then once you move it over, because I have natural logs on both sides, I can drop the natural logs, which tells me x equals 3. That works. Anybody do it differently? It's fine. That's the way I'd have done that one too.
This calculator's confusing.
Yeah. Well, I can't do anything else but give you that calculator. Okay, I've got 1/3 raised to the x equals 9. So what did we do on this one? Multiply by 3. So if you did that, you could do log base 1/3. But our base, we don't like it to be a fraction. I mean, we could do it that way, but that would be a headache. If I had log base 1/3, and I know your calculators will do it for you, so you don't even care. But I'm not used to having a calculator that does it. So that's not what I would try to do. I would try to rewrite 9 with a base of 1/3. So can I rewrite 9 to look like 1/3?
Yes.
How?
-2.
If I move 9 to the denominator, what happens? The exponent becomes negative, right, when I move it down. And then what is 9? Can I rewrite 9 in terms of 3?
Yes.
Yeah, I can. 9 is just 3 squared. And that's raised to the negative first. Now what do I have? I have a power raised to a power. That means I'm just going to multiply. So it's going to be 1/3 to the negative second. So that means x is equal to -2.
That's just no grounds.
If you got an answer, check with somebody beside you. See if they agree. Tell them how you got there.
That's just these four. That's all that is.
How do you do the log with bases on here?
You can't. You can only do base E and base 10.
On the I need my actual calculator.
Yeah, you should have had it. Are we ready to go over E?
Yes.
Okay, what did we get on E? Natural log is 7. What were your steps? How did you get there?
Added natural log to each side, so and then our natural log and e cancel out.
So you took a natural log of both sides. Okay? So if I take a natural log. Okay? So I need to move the exponent out front as multiplication. X times the natural log of E equals the natural log of 7. And then I think you said it.
Natural log and e cancel out.
Natural log and E are inverses. That becomes a 1. So X is the natural log of 7. All right, if you put that in your calculator, you'll get some ugly decimal number. Nobody wants to write that down.
Wait, so you did that because, like, isn't E like the base of it?
Mm-hmm. Yeah, so that's just the way she looked at it. Did anybody look at it a different way? What did you do, Hall?
I'm writing this down.
Okay, you're not sure? Did anybody try it differently besides taking a natural log of both sides? Because that's not the way I'd have probably done it. Okay, so you rewrote it from exponential form to logarithmic form. So what would that look like? It would be log base e of 7 equals x, right? If you switch from exponential to logarithmic. And then what does a log base e, how do we write that? Just as a natural log, right, is my shorthand. That'd be another way. That's the only two that I can think of. Did anybody do it a different way to get there? Okay. And what about f? Does anybody get an answer for f?
E to the negative 30 equals x.
Okay, and how did you know to do that? Or what were your steps?
Natural log is log base e.
Okay, so natural log is just another way to say log base e. And so then you rewrote it from logarithmic form to exponential. We're kind of doing the opposite from what we did on e. On e, we took an exponential form, rewrote it in logarithmic. Now we're taking something that's in logarithmic form, rewriting it in exponential form. So it's the base raised to the answer equals the argument, which in this case is x. So now I've got an x by itself. All right, that's my end goal. So that one is probably the hardest one we've had yet. So when I look at g, if I wanted to rewrite that from logarithmic to exponential, I'm going to say it's the base, which is 10, raised to the answer, which is -1, is equal to the argument, which is x. I'm just rewriting it from logarithmic form to exponential form. This is an acceptable final answer. Okay? Now, if you wanted to, you could have went ahead and simplified 10 to the negative first. Did anybody do that? All right, what is 10 to the negative first?
1/10.
1/10. That would also be acceptable. Either one is fine. All right? Questions on G. It's literally one step. All right? You just have to know, rewrite it from logarithmic to exponential. And then H is the same thing. It's just got a different base. What's the base here? 3. So I'm going to write this as the base raised to the answer is equal to the argument. Now this one I would definitely simplify. G was kind of, I'm okay if you leave it like that, or if you want to simplify it. 3 to the 4th is very easy to simplify, and it's going to give us a whole number. So I would definitely simplify that. So what is 3 to the 4th?
81.
81. All right. For sure. So let's see. How did y'all guys work A? I saw a couple different ways. Put it in logarithmic form. So what does that look like? Log. Okay. And then if you've got a Casio, you can put that directly in your Casio, right? You can find out what log base 2 of 512 is.
9.
Thanks. So that would be 9 is equal to x. Did anybody try it a different way? Because, again, I grew up in the pre-Casio era. I wouldn't have done that because I couldn't put in log base 2 in my calculator. I would have tried to rewrite 512 to give me a base of 2. So 512 is 2 raised to what power? So I was doing it in my head earlier. 2, 4, 8, 16, 32, 64, 128, 256, 512. So I can rewrite 512 as 2 to the 9th. Now that I have bases that agree, I can drop the base and set the exponents equal. That's the way I would have worked it. All right, but either one is fine. Questions on A? B part. What did you guys do on B part? There's really only one way to do this one.
Just put 6 to the 3rd.
You rewrite it from logarithmic to exponential. So 6 raised to the 3rd is equal to the argument x. And then what is 6 to the 3rd?
216.
216 equals x. Okay? Questions on B part? All right, C. C's a little different. Yep, you too. Yep, thank you. What does it look like on C? What did we try to do? What you try to do on C? You're great tryhards. What'd you do on C? That's what I would do. I would move negative e to the x to the other side and make it positive. And so now it becomes an exponential problem that I can rewrite as a logarithmic problem. Or you could take a natural log of both sides. Either one, those both work. Okay? So if I rewrite that as logarithmic, that's going to be the natural log of 5 is equal to x. Right? Log base e of 5 equals x. And then we're going to leave this as our answer. Right? Because it's going to be some ugly decimal. And then D part. Okay. You rewrote it as a logarithm?
Yeah.
Okay, so that would be log base 9 of 1/3 equals x. And then if you put that in your calculator, 9 raised to what power is 1/3? That's going to be negative 2.
I was thinking negative.
So how come the E just
Right? If you put this in your calculator, you got negative 2, right?
negative?
I could tell by the way everybody was looking at me.
There's negative 1/2.
Okay? Well, I wouldn't do it this way. I would try to rewrite them with the same base. So let's go through the process I would do. So it's always easier to take a bigger number and make it smaller. So I'm going to take 9 and turn it into a 3. That would be my thinking. So 9 is the same thing as 3 squared. Raise that to the x equals 1/3. Now I have a power to a power. So that means I can multiply. So 3 to the 2x is equal to 1/3. Now then, I need to change one or the other. I would move 3 to the numerator over there. If I move 3 to the numerator, that's going to turn it into 3 to the negative first. And now I have bases that agree. So I can drop the bases and set the exponents equal. So 2x is equal to negative 1, which means x is equal to, as you guys said earlier, negative 1/2. Okay? That's 100% the way I would have done it. Both challenging. They're just going to be ugly numbers, is really the moral of the story. So A really looks a lot like some we've already done. If I need to solve this exponential, because my variable is stuck in the exponent, I'm going to rewrite it as logarithmic form. So this would be log base e of 72 equals x. So just, the numbers are a little bit larger, but it's the same type problem. Now B is different. What looks different about B?
There's yeah.
There's what?
There's that 30 there.
The 3. So this time my power is being multiplied by a constant, 3. So before I can do anything, I need to isolate the power. I need to get 2 to the x by itself. And then I can start talking about, well, do I want to rewrite the bases? Do I want to rewrite it as a logarithm? You can't do anything until the power is isolated. So I need to get rid of the 3. What's the 3 doing to the power? Multiplying. So to undo that, I'm going to divide by 3. That tells me 2 to the x equals 42 divided by 3, 14. Now, can I rewrite 14 as a power of 2?
No.
No. So, again, you guys, Casios, what can you do? You can say log base 2 of 14 equals x. And you're going to get an ugly decimal. Okay? Now, what I would have had to have done is use the change of base formula. Do you remember at the very beginning of the last section, went over that change of base? Because I didn't like the base of 2 because it didn't help me. So what we'll do, this is kind of, I don't even know what I was saying. Okay, so what I'm going to do is I'm going to take a natural log of both sides. If I take a natural log of both sides, then what happens? I can move the exponent out front. You need to pay attention to this because there's going to be some problems later your Casio won't do. You're going to have to do it this way. I hate to tell you. I took a natural log of both sides. Anything you do to one side, you can do to the other. I pulled the exponent out front as multiplication, and I want to solve for x. X is being multiplied by the natural log of 2, so I'm going to divide by the natural log of 2. That tells me x is equal to this. Natural log of 14 over the natural log of 2. All right, what did we get on A? Natural log of 10 equals x. And then B part, what did we do? 5 to the x equals 16. Or we should have divided both sides by 2 first. And now if you're going to do it the way I'm asking you to do it, you're going to take a natural log of both sides.
And then you're going to have natural.
And so this is x times the natural log of 5 equals the natural log of 16.
And then you're going to divide by 5.
Divide by the natural log of 5.
Yes, sir.
Yes, sir. And so x is the natural log of 16 over the natural log of 5. Okay, so right here it's telling me to solve 4 times e raised to the 2x minus 3 equals 2. And so the variable that I am trying to solve for is stuck up in an exponent. So the first thing I want to do here is I'm going to isolate the power. I want to get the power by itself, which would be here. So I'm going to add 3 to both sides, which is going to give me equals 5. Now the power is still not isolated because it's being multiplied by 4. So I need to divide both sides by 4. That gives me e to the 2x equals 5/4. Or you could rewrite that as 1.25. Now I would use a change of base formula to get the variable out of the exponent. So I'm going to take a natural log of both sides. Now when I take a natural log of the left side, I can move the exponent out front as multiplication. So this is 2x times the natural log of e equals the natural log of 5/4. Well, the natural log of e is 1. So that cancels. And now to get x by itself, it's being multiplied by 2. So I'm going to divide both sides by 2. So I get as an answer x equals the natural log of 5/4 over 2. If it asks me for an exact answer, this is the exact answer. Okay, I can't simplify that anymore. If it asks me for a decimal answer, I'm going to put that in my calculator, and it comes out to approximately 0.11 when I round. Now let's go ahead and go over this one. So I would subtract 5 from both sides, which is going to be 24. Next, divide by 2. That tells me e to the 3x is equal to 12. And now to get the variable out of the exponent, I'm going to take a natural log of both sides. So that's going to give me 3x equals the natural log of 12. Right, because I'm moving the 3x out front, and then the natural log of e is canceling, and then divide by 3, and so I find that x is equal to the natural log of 12 over 3. Any questions on that one?
Could you simplify that down more? Like, if we put it in our calculator, it got 29.
Okay.
Is that,
I didn't know that it became 29. But if it becomes exactly 29, absolutely. Let's see, what is it?
just kidding, that's wrong. I'm wrong.
Okay. I didn't figure that would be a very pretty number. Yeah, I was looking in my book, and my book doesn't have it as 29 either.
Well, not really excited.
That's okay. Anything else on this one? Here. Okay, so I've got 2 times a power, and you can see that my variable is in the exponent of the power. Minus 4 equals 11. So what I need to do is isolate the power. I want to get this by itself. So the first thing I'm going to do is add 4 to both sides. So that's 3 to the 2t minus 5 equals 15. Next, divide by 2. So I get 3 raised to the 2t minus 5 is equal to, I'm going to make it a decimal this time, 7.5. You could leave it as a fraction. It doesn't matter. All right, now same principles. The variable is stuck in the exponent, so I'm going to do a change of base formula, taking a natural log of both sides. All right, here's where you have to be a little bit more careful. When this exponent comes down, all of it is being multiplied by the natural log of 3, not just the negative 5. If you're not careful, you will just leave the negative 5 in front of the natural log, and you'll make it look like the 2t is disconnected, like it's a constant, but it's not. That entire exponent comes out front, and all of it is being multiplied by the natural log of 3. So here's why that's important. Because now, in order to get t by itself, what I would do is I would distribute first. So if I distribute that, that becomes 2t times the natural log of 3 minus 5 times the natural log of 3 equals the natural log of 7.5. Now I've got 2t natural log of 3 equals, I'm going to move this over and make it positive. So I've got the natural log of 7.5 plus 5 times the natural log of 3. Now you got options. I would simplify this because I can make that a number. So this becomes the natural log of 3 to the 5th power. And then what is 3 to the 5th power? That would be 243. And the reason I did it is because it's just going to become a number. Now what do I have? I'm adding logs on the same side. So I can multiply the arguments. So I could rewrite that as 7.5 times 243. Which I can't do that in my head. At least not this morning I can't. 1822.5. So that was kind of like a little detour, right? Because my goal is still to get t by itself, but I'm just rewriting it a little bit simpler with a single logarithm. If you didn't see that, you're probably still okay. Like I said, there's multiple correct answers. There's multiple ways to get there. So anyways, I've got it simplified. Now I want to get the t by itself. t is being multiplied by 2 and the natural log of 3. So I'm going to divide by 2 and the natural log of 3. And that's going to give me t is equal to this monstrosity. So I've got the natural log of 1822.5 divided by 2 times the natural log of 3. When I do that, I get approximately, so I'm rounding, approximately 3.42. And that's what the book said as well. If I look at the way they did in the book, they actually did it differently than I did. They rewrote it as a log base 3. They chose to take a log base 3 of both sides. All right, that's also fine. So again, several different ways to do this. I'm just in the habit of always taking a natural log of both sides because that was our change of base formula. So I would subtract 4 from both sides first. Next, divide by 6. So I've got 2 to the t minus 5 equals 7/6. This time I'm going to leave that as a decimal or as a fraction because a decimal would be ugly. Now take a natural log of both sides. So that's going to give me t minus 5 times the natural log of 2 equals the natural log of 7/6. Now I would distribute. So this is t times the natural log of 2 minus 5 times the natural log of 2 equals the natural log of 7/6.
I think it's supposed to be plus 5.
Yeah, that's what I got. No, I don't know what you're talking about. Thanks. Okay, now get the t by itself. So I'm going to move the 5 natural log of 2 over. It's going to become negative 5 natural log of 2. And now t is being multiplied by the natural log of 2. So I'm going to divide by the natural log of 2. So I have to divide all of this by the natural log of 2, which tells me t is equal to the natural log of 7/6 minus 5 times the natural log of 2 over the natural log of 2. And now again, I could probably simplify this some more, but because that's so ugly to start with, I really don't have any interest in doing that. So I'm just going to leave it like this time. All right, if you did simplify it, that's fine. You can do it that way. Again, several different ways to get the correct answer. The thing I can tell you in the end is you need to just plug it in your calculator and get an approximation. That way, maybe if the book says something different than what you find as the answer, if your approximation is the same, then that means you've got the same answer. They've just written it in a different form. So when you plug this in, you should get approximately negative 4.78. And so I'm going to do that to check mine right now. So like I said, if you got something different, plug yours in and see if you get that same approximation. That's what I got. I got negative, hold on. I got negative 4.84. Natural log of 7/6 minus 5, natural log of 2. Oh, it's because of the order of operations. Hold on just a second. No, I can't do that. Natural log of 7/6 minus 5 times the natural log of 2. And then divide this by the natural log of 2. Yeah, that's right. Negative 4.78. Okay, so I've got e raised to the 2x minus 3 times e to the x plus 2. So what makes this problem different than the last ones we've been doing? Say again? More than one e and more than one x, right? This time I have two variables, and they're both in the exponent. So, like just running through possible solutions in my head, right? If I could get them on different sides, my powers, then I could drop the e's, right? If they had the same base. Okay, but that's not going to work because I'm stuck with this constant as well. So separating the powers isn't going to do any good. If I take a natural log of everything, of both sides, well, I have to take a natural log of all of this together. That's just going to be a mess. That's not going to get me any closer to getting the variable by itself. So when I look at that problem, what I see is almost a quadratic. Ax squared plus bx plus c. Right? It kind of follows that pattern. The only difference is right here I've got 2x, and right here I've got just x. So if you think about our rules, right here, I can think about this as 2 times x in the exponent. So I could rewrite that as a power raised to a power. So e to the 2x is the same thing as e to the x squared. Because now, think about it. This is a power to a power. I would multiply. That would give me e to the 2x. So that's my one change I need to make to my original equation. And now, do you see it? This is kind of like x squared plus x plus a constant. It really looks like a quadratic. So what we'll do is what's called a U substitution. Do you guys remember doing a U substitution? Yes, no, no, yes. Basically, e to the x looks really hard to work with. So we're going to work with a U instead. So I'm going to make U be equal to e to the x. And I'm going to substitute in everywhere I see an e to the x, I'm going to write a U. So this becomes u squared minus 3u plus 2 equals 0. Now it definitely looks like a quadratic. What I'm going to have to do now is solve this quadratic, and then I'm going to go back and plug this back in at the very end, once I've done all the other math that goes along with it. So now how could I solve this quadratic? I can factor. I could use the quadratic formula. For me, looking at this one, I would factor it. What multiplies to be 2 added is negative 3. Yep, and both of them negative. Right, so I've got u minus 1 times u minus 2 equals 0. Now I've got two things multiplied to be 0, so either the first thing is 0 or the second thing is 0. This means u is 1 or u is 2. So now I've completely solved. The only problem is my answer is in terms of u, but I want my answer to be in terms of x. So now, once I've completely solved it, I'm going to substitute back in. So instead of saying u equals 1, I'm going to say e to the x equals 1. And instead of saying u equals 2, I'm going to say e to the x equals 2. So substitute back in. Now to solve for x is stuck in the exponent, so I'm going to take a natural log of both sides on both equations. So that's going to tell me x times the natural log of e equals 1. And this is going to tell me x times the natural log of oh, hold on, I'm a moron. I knew something was not working out right. There we go. X times the natural log of e equals the natural log of 1. There we go. And x times the natural log of e equals the natural log of 2. Okay, so the natural log of e cancels. So I've got x equals the natural log of 1. What is the natural log of 1? Think about what that's asking. E raised to what power is 1? 0. So I get x equals 0 from the left. And then over here, natural log of e cancels, and I get x equals the natural log of 2. That one does not simplify. So I have two solutions. X could be 0, or x could be the natural log of 2. Okay, so same idea. We're going to rewrite this as e to the x squared minus 7 times e to the x plus 12 equals 0. Perform a u substitution and then substitute it in. So I get u squared minus 7u plus 12 equals 0. That factors to be u minus 4 times u minus 3. So I get u equals 4, u equals 3. Then substituting back in, I'm going to get e to the x equals 4, e to the x equals 3. Take a natural log of both sides for both equations. So x is equal to the natural log of 4, and x is equal to the natural log of 3. Works. Okay, so A part. I've got the natural log of 3x equals 2. Now I'm trying to solve for x. This time x is stuck in the argument. So in order to get it out of the argument, I'm going to rewrite this as an exponential equation instead of a logarithmic equation. So natural log has an understood base of e. So if I rewrite this, this is e to the second equals 3x. Now that's really easy to solve. Get x by itself. X is being multiplied by 3, so I'm going to divide by 3. That tells me x must be equal to e squared over 3. So now again, in my calculator, I'm going to go plug this in here. So like all I'm going to do, I'm going to type in 3 times e squared over 3. Okay, so when I type that in, 3 times e squared. Where's my e button on this calculator? There it is. 3 times e squared over 3. I get 7.389, right? So my argument is positive. Therefore, it didn't break the logarithm. So that works. All right, I'm just always plugging in, making sure my argument is positive. Everybody understands what I'm saying? Okay, B part. Now what's happening on B part? I have a logarithm on both sides of my equation. Now is the logarithm the only thing on both sides of the equation? It is. Like you see there's no constants on the outside. There's nothing being multiplied in front of the logarithms. They are isolated logarithms on both sides. And the logarithms have the same base. They both have a base of 3. That means we can drop the logs because they're the only thing on each side and they have the same base. So that tells me the arguments must be equal. 5x minus 1 must equal x plus 7. Now solve. Subtract x. That tells me 4x minus 1 equals 7. Add 1. 4x equals 8. And then divide by 2. Or sorry, divide by 4. Which tells me x is equal to 2. Okay, now I've solved it, but I've got to make sure that this will work. So I'm going to take 2 and plug it in for the arguments. 5 times 2 is 10. 10 minus 1 is 9. That's fine. That's positive. 2 plus 7 is 9. That's fine. Still positive. So x equals 2 is the solution. So A part, we should rewrite this in exponential form. E to the 2/3 equals x. And I've solved it. Right, you could plug that back in, but you know that e raised to the power is going to be positive, and there's nothing else to plug in. So that is fine. That's my answer. Questions on A? B part, I have logs on both sides. They're both log base 2. I can drop the logarithms. That tells me 2x minus 3 equals x plus 4. Subtract x. So that tells me x minus 3 equals 4, and then add 3. So x equals 7. Now I need to plug that in to make sure it works. 2 times 7 is 14. 14 minus 3 is 11. That's good. And then 7 plus 4 is 11. That's good. Okay, here I've got 5 plus 2 times the natural log of x equals 4. So if I'm trying to get x by itself, x is stuck in the argument. So the first thing I need to do is isolate the logarithm. I want nothing but the logarithm on its side of the equation. So I'm going to subtract 5 first from both sides. So I subtract 5, that tells me 2 times the natural log of x equals -1. Now I can divide by 2 on both sides. That tells me the natural log of x is equal to -1/2. And now I can rewrite this in logarithmic form. That's e raised to the -1/2 equals x. All right, I'm going to plug that into my calculator to make sure it gives me a positive number. And it does, right? Because when I plug that in, that's the only thing I'm plugging into. There's nothing else happening in the argument. So that keeps my argument positive. Therefore, that's my solution. Okay, so I'm going to subtract 7. So that tells me 3 natural log of x equals -2. Divide by 3. That tells me the natural log of x equals -2/3. And then rewrite this in exponential form. E to the -2/3 equals x. And again, I plug in, that will work. Okay, so same idea, except now we're not dealing with a natural log, we're dealing with a log base 5. But I still want to isolate the logarithm first. So that 2 that's being multiplied out front, I'm going to divide by 2. So that's going to give me log base 5 of 3x equals 2. And now rewrite it from logarithmic to exponential. That says 5 to the second equals 3x. Well, 5 to the second is 25 equals 3x. Divide by 3. That tells me x must be equal to 25 over 3. Now again, plug in. Make sure it does not make the argument negative. So 3 times 25 over 3, that's going to be 25. So the argument is still positive. Therefore, this works as a solution. All right, maybe you've already done this one. We're going to divide. Oh, yep. This is the one you're supposed to be doing on your own. Divide by 3. So that tells me log base 4 of 6x equals 3. Then rewrite it. 4 to the third equals 6x. 4 to the third is 64 equals 6x. Divide by 6. That tells me x is equal to 10 2/3. That's going to be 32 over 3. And then again, plug this in to make sure it doesn't break your argument. 6 times 32 over 3, that's going to give you 64. So again, the argument stays positive. So now I've got the natural log of x minus 2 plus the natural log of 2x minus 3 equals 2 times the natural log of x. So because I have so many logarithms, I want to get isolated logarithms on both sides. That way I can drop the logarithms. So right now on the left side I have 2 logarithms, but they're both log base e, and there's addition between them. So I can rewrite addition of logs as multiplication of the arguments. So this is the same thing as x minus 2 times 2x minus 3. So now on the left side I have a single logarithm. That's nice. On the right side I have a single logarithm, but right now it has a 2 in front of it. So I need to rewrite it so that 2 is no longer in front. So I'm going to make it an exponent. So that becomes the natural log of x squared. Now I have isolated logarithms on both sides with the same base. I can drop them and set the arguments equal. That means x minus 2 times 2x minus 3 has to equal x squared. And now I'm going to solve. So right now, it looks kind of ugly. So let's distribute, get a better idea of what we're dealing with. So I've got 2x squared minus 3x minus 4x plus 6 equals x squared. Now let's get everything to one side and combine my like terms. So when I move this x squared over, that's going to become 1x squared minus 7x plus 6 equals 0. So now I have a quadratic. So to solve the quadratic, I can either use the quadratic formula or factor. This one's easy enough to factor. It's going to be x minus 6 times x minus 1 equals 0. And then solving them, I find x equals 6 and x equals 1. So this time I have 2 possible solutions. Do I know that both of these work? Not yet. I need to plug them in to make sure it does not make the argument negative. So let's plug 6 in. 6 minus 2 is 4. That's fine. 2 times 6 is 12. 12 minus 3 is 9. That's fine. And then right here I'm just plugging in 6. That's fine. So 6 is good to go. Let's plug in 1. 1 minus 2 is negative 1. That's not allowed. I cannot have a negative argument. Therefore, 1 does not work. The only viable solution is 6.